This is the buffer problem set, problem 1A, and we're looking at a solution of propanoic acid, and they give us the formula, and it tells us it's Ka. So essentially, I'm just looking at what happens when I put propanoic acid, HC3H5O2, in water. And it's going to be in equilibrium. It is a weak acid because it's giving me the Ka. And so I know it's going to dissociate into propanoate, C3H5O2 minus. This would be the conjugate base of this weak acid. And it will also make some H3O plus because it is an acid, and I know that's what's going to help me figure out my pH if I need to. I'm going to table the Ka for a second, and I know my initial concentrations, but ultimately I know if I have a weak acid or base, I have to find my equilibrium concentrations by doing an ice table. I start with 0.1 molar propanoic acid. What that means is water doesn't matter because it's a liquid. I can just scribble it out. I don't start with any of the propanoate ion or the hydronium ion. So my change, because I noticed there's an imaginary 1 in front of there, would be minus x, and plus x. Obviously, I'm going to be taking away some of the propanoic acid and making some of these two things as it reaches equilibrium. So I have 0.1 minus x, and x over here. Now it's time for me to write my Ka. Ka equals the products over the reactants. Only aqueous or gases can be in the Ka. So C3H5O2 minus the propanoate ion, and then the hydronium ion over propanoic acid. And I know this value is 1.3 times 10 to the negative 5. They give that to me. And now I can plug in my x's for that. So on the top, I actually end up with x times x, or x squared, divided by 0.1 minus x. Now, my thought is, because this acid is so weak, and I actually have a decent concentration of it, 0.1, my change is probably going to be so small that I can ignore this x right down here. This minus x I can ignore, and we'll check it after we do the problem and make sure that this assumption is true. So I'm going to multiply 1.3 times 10 to the negative 5 by 0.1, and I'll get 1.3 times 10 to the negative 6 equals x squared. Take out your calculators. Don't be lazy because I'm calculating. So I'm putting into my calculator the square root of 1.3 times 10 to the negative 6, and I get 1.14 times 10 to the negative 3. And now I have to go back and say, what's the problem? Well, in my original problem, it says calculate the pH. So in order for me to calculate the pH, I know that pH, sorry about that, you couldn't see my calculations, equals negative log of the concentration of H3O+. Well, I happen to know that x is my concentration of H3O+. So I can do pH is negative log of the answer I just got, 1.14 times 10 to the negative 3. And get out your calculator. Don't be lazy, because now I have to do it. So I'm going to do negative log of my answer, and I get a pH of 2.94. Now that to me makes sense. 2.94 is definitely acidic, and this is definitely an acid. Let's go back for 1 second and take a look at that x value. Remember how we ignored it up here? Let's just double check and make sure that we can do that. We know that if we look at the change, so in this case x is my change, if it's less than 5% of my original concentration, that means it's small enough that it's not going to make a difference. Say you had 100 cookies and someone took 5 of them. Not going to make a huge difference. But if you had 100 cookies and someone took 50 of them, that's going to matter. So what we do as our check, and this is a totally separate thing, it's actually not part of the problem, it's just you justifying that we can make this decision and get rid of this x. I'm going to say that I'm going to take my change divided by my initial times 100 has to be less than 5%. So if I do my change, which is x, so 1.14 times 10 to the negative 3, divided by my initial concentration, which is 0.1, times 100, what do I get? So if I put that in my calculator, divided by 0.1, I get 1.14. Because the change is only 1%, it doesn't actually make enough of a difference that it's going to matter up here. So this assumption that we got rid of this x is okay. So my official answer that the pH is 2.94 is all set.